All right, welcome to 13.2. We're learning about sine, cosine, and tangent today. So remember that sine, cosine, and tangent are all types of trigonometric functions, and they compare certain sides within a right triangle specifically. So here I've outlined for us, if we're given this angle, we're going to call this angle theta. Theta is just a Greek letter like pi or alpha. And this Greek letter theta is most often used with trigonometry just to describe an angle, okay? But it's the same thing as x or capital A or anything like that, it's just a variable. So when I look at this angle specifically, theta, right here, this blue side would be called the adjacent side. Adjacent means next to. This red side would be opposite because it's completely opposite the triangle. And the purple side here would be called the hypotenuse because it's the longest side. Remember, the longest side is always opposite the right angle. So some people sometimes they make the mistake and they call this the adjacent side, but that can't be the adjacent side because there has to be a hypotenuse, and we know the hypotenuse is always opposite the right angle. So don't make that mistake of calling the hypotenuse the adjacent side. The hypotenuse is always the longest side, and then the adjacent is the other side that's next to your angle. So if I think about sine, it's spelled out S-I-N-E, but we abbreviate it S-I-N. Please do not say sin, that would be incorrect. It's called sine. So the sine compares the opposite side, and it also compares the hypotenuse. All right. The cosine, which is abbreviated C-O-S, but again, don't say cos, just say cosine. The cosine compares the adjacent sides with the hypotenuse. And then last one, the tangent, which is abbreviated T-A-N, but again, don't say tan, just say tangent. The tangent compares the opposite side to the adjacent side. All right, so those are kind of all the combinations that we can do with the three sides of a triangle. So it's important to remember which trig function, sine, cosine, and tangent, belongs with which comparison of sides. So the way we remember that is something called SOHCAHTOA. Maybe you've heard that before. But this is an abbreviation kind of that helps us understand what trig function compares which sides. So for example, the sine compares the opposite side divided by the hypotenuse. The cosine compares the adjacent side divided by the hypotenuse. And the tangent compares the opposite side divided by the adjacent side. All right? So here we're going to identify these following trig values. We're just going to leave our answer as fractions. And so in this right triangle ABC, we've got the three side lengths. And I'm trying to look for the sine of A. So if I'm looking for the sine of A, I'm really just focusing on this angle A right here. And I know that sine is opposite over hypotenuse. So the side opposite, angle A is 4, and we know the hypotenuse is always the longest side, which is 5. So if I look at the sine of A, I'm just trying to do 4 over 5, right? 4 is the opposite side, and 5 is the adjacent side. If I'm looking for the cosine of A, well, the cosine of A is just going to be the adjacent side divided by the hypotenuse. So this ratio would be 3 over 5. And if I'm looking for the tangent of A, we know that tangent is opposite over adjacent. Well, we said the opposite side is 4, the adjacent side is 3. So this would be equal to 4/3. If I'm looking for the sine, cosine, and tangent of my angle C, well, now I'm focused on angle C here. So if I look at angle C, if I'm trying to find the sine, we know that sine is opposite over hypotenuse. So opposite C would be 3, and the hypotenuse is 5. So this would be 3 over 5. If I'm looking for the cosine of C, cosine we know is adjacent over hypotenuse, so that would be 4 over 5. And if I'm looking for the tangent of C, we know that tangent is opposite over adjacent, so that would be 3 over 4. Okay, so notice your tangents change in value depending on which angle you're looking at. Okay, so it totally depends on what angle you're looking at. I like to circle the angle in the problem, that way I kind of have a clear view of which angle I'm working with and which sides I need to focus on. All right, one thing that you might notice is that these values for sine and cosine will always be less than 1. The reason why these are always less than 1 is because your hypotenuse is the longest side. All right, so these will always be less than 1, okay? If I have a smaller side over the largest side, this will always be a fraction that's smaller than 1. So this will never be like 1.2 or 3 or 4 or anything like that, okay? Sine and cosine, you're always going to get fractions that are less than 1. The tangent, however, is a little bit different, okay? It depends on which angle you're looking at, but we can see sometimes this is bigger than 1. Sometimes it's less than 1. All right, this just depends. So there's not really any limit on the tangent. This can be greater than 1, or less than 1, okay? Doesn't really matter. It could even equal 1. All right, so it could be anything for the tangent, but the sine and cosine are limited to what they can be. They have to be less than 1 for their trig ratios. So here we're going to use these trig ratios to find some of the unknown sides of the triangle, and we're going to round our answers to the nearest hundredth. So first, let's first try to find side x here. So if I'm trying to find side x, the only angle that I'm given is this angle right here. Now I could figure out this missing one. We know that all angles in a triangle have to add up to 180. So I could find that missing angle, but because I already have the 42, I'm not going to worry too much about that missing angle there. So if I'm focusing on this angle 42 degrees, I'm trying to incorporate the side that I already know and the side that I'm trying to find, okay? I don't really care about this side y right now, so I'm going to kind of forget about that letter y. I'm just going to focus on the x, the 13, and the 42, all right? So doing so, I need to make a decision and try to figure out which trig function I'm going to use, right? Should I do the sine of 42, or the cosine of 42, or the tangent of 42? And that all depends on the relationship of these two sides. So if I'm, again, focusing on that 42 degrees, I know that x is the opposite and 13 is the adjacent. So I want to think about which trig function I would use that incorporates the opposite and the adjacent, and I know that's got to be the tangent, okay? So we're going to use the tangent of 42. So I'm going to go ahead and erase this. And I know that if I'm using the tangent of 42, this is opposite over adjacent. So this has to be x over 13. I can't do 13 over x because tangent is not adjacent over opposite. It's opposite over adjacent. So I'm going to go ahead and try to solve this now for x. To solve this, I just want to get rid of that denominator. So tangent of 42 equals x over 13. I want to multiply both sides by that 13. And here the 13's cancel. So we end up with x is equal to 13 times the tangent of 42. At this point, you will have to use your calculator. So you're going to type in 13 times the tangent of 42, and you're going to hit equals, and you should get an answer of 11.71. All right? It says round to the nearest hundredth, so I left it like that. But you would get a decimal that does go on forever, so make sure you round that. All right, so that's our value for x. We found x, great. And now I have to go ahead and I have to find y. So I'm going to look for y, again using that same idea. So I have to figure out if I'm going to use the sine of 42, the cosine of 42, or the tangent of 42. So if I look at what I'm given in comparison to that 42, we know that y is the hypotenuse and 13 is the adjacent. So my trig function that uses the adjacent and the hypotenuse is the cosine, right? Think of SOHCAHTOA. So I'm going to use the cosine of 42. And we're going to say that the cosine of 42 we know is adjacent over hypotenuse. So it has to be 13 over y because 13 is the adjacent and y is the hypotenuse. Now to solve this, I do still want to get rid of that denominator. So I'm going to start by multiplying both sides by y. So times y and times y. The y's will cancel. And now I have y times the cosine of 42 degrees equals 13. I'm not quite done yet because I do want to get y all by itself. So I'm going to divide both sides by the cosine of 42. And we do get those to cancel on the left. And so now you're just going to go on your calculator and you're going to evaluate 13 divided by the cosine of 42. And you should end up with an answer of about 17.4. Okay, that is a rounded answer, but that should be our answer for side y. Okay, so we found x, we found y, which is great. We said that y was 17.49. And we said that x was 11.71, okay? Now, a really quick way to check your answer that's kind of easy just to make sure you're in the ballpark is make sure that the hypotenuse is the longest side. So if you look at your three sides of 13, 11.7, and 17.49, just make sure that the longest side is the hypotenuse. All right, so I'm gonna go ahead and try the next problem here. Now the next one we do have to set up our own triangle. So given right angle M, I'm gonna draw a right triangle with angle M right here. This is triangle MNP, so I'm gonna just call that N and call that P. I could have called the other angles P and N, vice versa, but that's okay. And now we wanna use the information to find M. So if you haven't realized yet, when we label these triangles, the opposite side is always the lowercase version of the capital angle. So if I go across this triangle, this side here would be lowercase m. If I go across the triangle here, this side would be lowercase p. And if I go across this triangle here, this would be lowercase n. All right, so we've got all the sides labeled, and we know that lowercase n is 6.3 centimeters. We know that angle n is 24 degrees, and I'm trying to find angle M right there, okay? So if I'm trying to find angle M, if I'm trying to find side M, and we know that this side is 6.3, and we know this angle is 24, these are the three pieces of information that I have to work with, okay? So again, I'm thinking to myself, am I gonna have to do the sine of 24, the cosine of 24, or the tangent of 24, all right? And again, that depends on the location of these two sides. Well, I know that in relation to the 24-degree angle, n is the opposite side, and m is the hypotenuse. So I have to think about which trig function uses the opposite and the hypotenuse, and that is going to be the sine. All right, so I do have to use the sine of 24. And we're going to say that the sine of 24 degrees equals the opposite side, which is 6.3, over the hypotenuse, which is m. Okay, so now I again want to get m out of the denominator, so I'm going to multiply both sides by m. We see that the m's cancel on the right side, so now m times the sine of 24 equals 6.3. When I divide both sides by the sine of 24, we can then head over to our calculator and we'll find out what m equals. We should give an answer of about 15.49. All right, and we're going to put centimeters on that. Again, quick way to check is just to make sure that because m is the hypotenuse, it does have to be longest, so it should be longer than 6.3, and it is in fact longer than 6.3. So one quick shortcut I want to teach you, and maybe you've noticed this, is that when I try to evaluate and I have my variable in the denominator, okay, what is kind of happening is I'm basically switching this sine of 24 with the m, okay? So this is really the same thing as m equals 6.3 over the sine of 24 degrees. And we can see that's what we got right here. It's just kind of a quick observation that we can make to save ourselves some time. So for example, this is a separate problem here. Let's say I was asked to solve this problem. Let's say I was asked to solve the tangent of 17 degrees equals 21 over x. So I could go ahead, I can multiply both sides by x and then divide by the tangent of 17, but we can notice from the previous problem that that shortcut is just to switch these. And so that would really mean that I have x equals 21 over the tangent of 17, and then I can just go to my calculator and figure out what that number is. Now that's different than if I had tangent of 17 equals x over 21. Right? If this is the case, if x is in my numerator, then I would just go ahead and I'd multiply both sides by 21. And when these cancel, we just get x equals 21 times the tangent of 17. Okay? So this kind of shortcut method only works when your variable is in the denominator, but it does kind of save you a step and does save you a little bit of time once you get more comfortable with these types of problems.